Hello friends, this video limits and derivative part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. So we have to prove that cos x is always less than sin x by x, and that is always less than 1 for x is between 0 and pi by 2. So what we see in this is a circle and this is a triangle, this is also a triangle. So if you see that the area of OAC, if you take this triangle, this and this, the three dotted points I have made, in this triangle, the area of this triangle will always be less than the area of this sector OC. I'll put a dot here again. This sector which you get OCADO, correct? And this area will always be less than the bigger area, this one, that is OBA. You can see that. So if you see that this value OCA is this much alpha. This is the value of OCA. You see OCA is this much, right? So if you see on all these three, we have this this thing common. This line. This is OCA. Now on top of that, if you add this area, that is arc area, this is again bigger, and again on top of that, if you add this area, this is again bigger. So we can say that area of triangle OAC is always bigger than area of sector OAC, because this sector includes also the curve area, and this is always greater than area of triangle OAB. Correct? Because OAB is a bigger triangle. You can say smaller triangle area is always greater than this sector, because this sector includes this area also, and that is again always bigger than the bigger triangle, that we can say. Now area of triangle OAC is nothing but 1 by 2 into OA into CD. CD is the height of this CD, and this is always greater than. Now we have to find the area of the sector. So area of sector, the angle is x degree, so we'll convert into radian. So x by 2 pi, this is the radian, into pi into OA into OA, right? Pi r square. This angle into pi r square. This angle is x by 2 pi into r square, because x is in radian actually. This x is in radian, not in degree. So x by 2 pi is for the whole thing, 360. So that's the formula of any sector which is a pi x radian. So the formula is x by 2 pi into pi r square, pi into OA into A, and area of this triangle OAB is nothing but 1 by 2 into OA into AB. Correct? Now we see that OA is common in all, so we can cancel OA, it is not 0. Correct? 1 by 2 is also common in all, so we'll cancel this 1 by 2. Here pi is common, we'll cancel. What we are getting here is CD is always less than x into OA is always less than A. Now we have equation in the term of CD, OA and OB. Correct? What we have to find? The equation in the form of cos x sin x x. So if we can just find how we can find this, we can write this CD, OA, OB in sin x cos x terms, our problem is solved. And we can very well do it, because we know that in any triangle, we know this angle. We can say, for example, in this triangle, we can say that cos x or tan x is equal to CD by OD. So we can do in any triangle. So let's try. We'll take this triangle ODC. This triangle will take. In this triangle, if you want to find the value of sin x we know this Pandit, Badri, Prashad, Hari, Bol. So sin x is P by H. So P is CD and H is OC, right? So we can say that in this triangle, we'll write in triangle OCD. In triangle OCD, we can say that sin x is nothing but P, that is P is here CD, because this is the angle X, this is 90 degree, this is CD, P is CD by H is OC, correct? Now but we don't have OC here, we have CD, yes, we have CD here, we have OA and AB. we can see that this OC is R, OA is also R, correct? So we can write OC is equal to OR. We know that here OC is equal to OR, OA is equal to R, because both these are radius. So we can write this CD by OC as nothing but CD by OA. So with that we know that we have CD, OA, everything in this equation. So the first equation we get here is, I'll write here, is sin x is equal to CD by OA. That is the first equation we have. Correct. The second equation we can get is in triangle OAB. In this triangle OAB, if we want to find the value of tan x, why? Because we have AB here, and AB will always come in tan only. So in triangle OAB, if we see, tan x will be AB by OA. Correct. And we have AB here, we have OA here. So we'll say that tan x is equal to AB by OA. So we have equation 2. Now what we can do is, we can just substitute the values here. So if you see, CD is nothing but OA sin x. So instead of CD, I'll write OA sin x. OA I can leave it now because I feel that OA will get cancelled. AB I can write as nothing but OB tan x or OA tan x. OA tan x. Correct. Now we see OA is common again here. So we'll cancel OA part. So what we get here is sin x is less than x and is less than tan x. Sorry, OA part is cancelled, not the tan x. This part is not cancelled. OA part is cancelled. This is tan x. Tan x I can write as nothing but sin x by cos x, right? So let me write this as, this is nothing but sin x is less than x is less than sin x by x. Correct? Now we'll divide the whole thing by sin x, because we have sin x here, sin x here, sin x here, and the middle term should be x by sin x. Correct? So we'll divide the whole thing by sin x. So this becomes by sin x, this becomes x by sin x, and this becomes 1 by sin x. This cancel. So what this becomes cancels, becomes 1. So what we get is 1 is less than x by sin x and is less than 1 by cos x. That is what we have got till now. Now what we'll do, we'll take a reciprocal. We'll take a reciprocal. So if we take a reciprocal, 1 by cos x by 1 by cos x, this becomes cos x, and this comes this side. So this becomes this. X by sin x becomes sin x by x, and 1 by 1 is 1. And that is what we have to. Correct? This is what we have. What we have done, we have used the sandwich theorem here. So we have seen that in this case, our area of triangle OAC was less than area of sector OAC, and that was again lesser than area of triangle OAB. We have found a value of, or the formula of the area. We have found OA and 1 by 2 was common. We cancelled that. We have got this equation in CD, OA, OB term, but we wanted to find this equation in sin x and cos x form. So we have got these two equations, sin x is equal to CD by OA and tan x is equal to AB by OA, and we have replaced this value of CD and AB here in this equation. So we got this sin x is less than x is less than tan x. We have written tan x as sin x by cos x, and we have divided the whole thing by sin x. We have got this equation, and we have taken the reciprocal to get the answer, that is cos x is always less than sin x by x is always less than 1. Using sandwich theorem, we have proved this. Here we have to prove that sin x by x limit x tends to 0 is equal to 1. So what we will do here? Here we will say, we'll again use the formula which you have derived in the previous example, because if you say here sin x by x equal to 0, if you put this becomes 0 by 0, that is 0 by 0 form. So that means we can do something for this. We can try to write this in the different form. So we have this derivation derived that cos x is always less than sin x by x, always less than 1. Correct? Or we can say equal to also, because there can be a case where x is equal to 0 and x is equal to pi by 2. So this is the case. We have to find this value for x is equal to 0. So if we can prove that for x is equal to 0, this value is, for example, k for x is equal to 0, for x is equal to 0, and this value is also k. So in that case, we'll say this value is also k. Sandwich theorem, because we are told that this cos x is always less than equal to sin x, is always less than equal to 1. So we can prove that for x is equal to 0, this value is k and this value is k, same values, then we can prove that sin x by x is always also k. So for x is equal to 0, cos of x is nothing but cos of 0, that is 1, correct? And for x is equal to 0, 1 is always 1. If you want to write it in the limit form, you can say that limit of x is equal to 0, cos x is equal to 1, limit of x is equal to 0 and 1 is equal to 1. So if you see, both the values are same. Thus we can prove by sandwich theorem. Now I can now assume by sandwich theorem that sin x by x, limit of x tends to 0 is nothing but 1. I can prove using sandwich theorem. Why? Because we were told that sin x is always less than equal to 1 and greater than equal to cos x, and then we have found the values of cos x at x tends to 0 and 1 at x tends to 0, actually 0. Both the value came out to be 1, and since the values are same, we can confirm from sandwich theorem that sin x by x is equal to 1 for x tends to 0. So in this example, we have to prove that 1 minus cos x by x, limit x tends to 0 is equal to 0. Again, first let's just put the value 0. What we get? 1 minus cos 0 is 0. Cos 0 is 1. Cos 0 is 1 by 0. That is 0 by 0 form. That means we can do something for this. So what we can do, we will rewrite this. 1 minus cos x we know is nothing but 2 sin square x by 2. You know this. 1 minus cos x is nothing but 2 sin square x by 2. So we can write this as 2 sin square x by 2 by x, limit x tends to 0. Correct? Or we can write this as nothing but sine of x by 2, right, into sine of x by 2, and this becomes by x by 2. Just 2, I will take this side, right? The whole thing, limit x tends to 0. Or I can write this as limit of x tends to 0, sine x by 2 into limit of x tends to 0, sine of x by 2 by x by 2. I can write this. Why? Because we know that limit of x tends to a for, let's suppose, pq is nothing but limit of x tends to a, equation p, into limit of x tends to a. This we know, right? Same thing we have used, limit of x tends to 0 for this two values pq is equal to limit of x tends to 0 p into limit of x tends to 0 q. Now this value, we'll put the value of 0 here, so this becomes sine of 0 by 2 into this value. We know that limit of sine x by 2 by x by 2, x tends to 0 is equal to 1. We have solved this in the last example, that sine x by x, limit x tends to 0 is 1. So x tends to 0, we can say x by 2 tends to 0, 1 is the same thing, because x tends to 0 and x by 2 tends to 0, 1 is the same thing. So this becomes 1. So this is equal to 1. Sine 0 is 0, 0 into 1. So this value is 0. Very simple. What we have done, we have just rewritten 1 minus cos x as 2 sin square x by 2. And then we have rewritten this equation into this form. And we have used the formula limit of sin x by x, where x tends to 0 is 1. And we have got the answer. In this thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.